Welcome everybody to our video series on computer programming for mathematics. I, as always, am Dr. Lathram, and you can usually find me in the Department of Mathematics at Missouri Southern State University. So today, let's get started on our Introduction to Python for Scientific Computing. So now, we will be using Python, in particular Python 3 for this particular video series. And so a reasonable question is what is Python and why would we choose to use that language in particular? Well, Python was developed by Guido van Rossum back in 1989, so that's probably potentially maybe older than a lot of people who are actually watching this video. One nice thing about Python is that it's free, open source programming language, and free, of course, everybody knows what that means. Open source really means that it's freely available to the public. Everybody can look at the internals of the program, see how it works, contribute to its development, and so it's not really owned by anyone in particular, hence that's why it's free. And so open source programming is really an amazing thing, at least for academic development and those kinds of things. It's a fantastic thing. The programming language, Python in particular, it's available on all platforms. So whether you like Windows, whether you like Mac, whether you're a Linux user, it's going to be available to you. And it is what's referred to as a high-level programming language. Now, what does that really mean? Python is not a compiled language. It's an interpreted language, and so in that respect, it's completely different than a programming language like C or C++ or Fortran. The interpreter, we will write scripts, so we will write code, and that code, whenever it's run, it will be sent first to the Python interpreter, and the interpreter will handle kind of all of the fundamental operations, such as memory management and declaring variables and those kinds of things. We won't have to really worry about any of that. It will be taken care of for us in the background, which is kind of nice. The syntax for using Python is pretty straightforward if you've ever seen some Python code. We'll look at some in just a little bit. The syntax is pretty straightforward. It's pretty easy to read, and that really makes it nice if we are developing programs quickly. If we have a problem and we want to prototype a solution for that problem, then chances are we can code the solution fairly quickly, run it, see how it's going to work, and Python allows us to do that. Nice thing about Python, there are an extensive number of modules. So modules are kind of the equivalent of libraries over in C, so we can incorporate other little pieces of code to make our job of writing easier. So things like SymPy, SciPy, NumPy, Matplotlib, Pandas, etc., all those things, and that's just a few of the thousands of modules that are out there to help you with whatever it is that you are actually doing. Now, there is, of course, downsides to everything. So if you gain somewhere, you lose somewhere. Downside of Python is that it's not really as fast as a lot of our compiled languages like C. If you want speed, then C is your programming language of choice. So that's going to go about as fast as you can go without writing assembly language, and that is tedious and time-consuming. So, it's easy to develop programs. It's maybe not as fast in implementation as what we would like it to be. However, modules like our SciPy and NumPy, they actually are compiled C underneath the hood, so there's kind of Python wrapped around them to use them, to call them, but basically they are a C program, which kind of mitigates the slowness a little bit, and we'll still get some pretty good speed. For most of what we will be handling, that really won't be an issue. If you were a really serious coder out solving this later on, further down the road, then I would probably advise you to learn a language like C. That pretty much everything you'd want to do, C, C++. If you want to learn C, probably C and Python will take care of the vast majority of a lot of things that you would encounter in scientific computing. And so now let's take a look at what we will actually be doing in this video series and looking at Python and scientific programming. So kind of our introductory Python programming course to get us kind of up to speed with Python in itself. We'll be looking at the Python shell, the types of objects that are available in Python, flow control, kind of working with files, reading and writing, of course, and then user-defined functions. Kind of the next level of programming, so a little bit more on programming, we'll be talking about errors and exceptions whenever we're writing our code. So if an error is thrown, how do we catch it and how do we fix it? So modules, so if we're writing some of our scripts, then we may want to use some of our scripts to be incorporated later in other scripts. And so a little bit of an overview of modules and packages and how that goes. And then just kind of touch on some object-oriented aspects of Python. Now, object-oriented, the objects in Python, so more about this. We'll get a bigger introduction to that one, which we're talking about functions and how objects are passed to in Python. Are they? So it's kind of an unusual thing. So a little bit on the object-oriented programming part. Then we'll get into the real kind of math part of it. So where we're using NumPy, using arrays, how is it used in statistics, using polynomials, so calculating with polynomials, doing a little in linear algebra, so probably anything that you're dealing with computers, somewhere along the way, linear algebra is going to appear. And then DFT, so discrete Fourier transform. So if we're doing any kind of signal analysis or anything like that, then it's good to know how to do a DFT. Matplotlib and Pylab, so what those are usually for plotting. So if we want visual representations of our data, or if we're doing animations or something like that, then how do we do that? Well, Matplotlib and Pylab is going to show us how to do that. Then SciPy, so SciPy calculations with doing numerical integration, solving differential equations, and other kind of numerical techniques when we're doing optimization, or we're finding roots of polynomials, or if we're doing some kind of linear regression, those kind of things. So we'll cover a fair amount of mathematical ground at the end. And then, so hopefully this will give you a pretty good overview of what we're looking at and where we are going. All right, so now let's take a look at what it seems like to install Python under. In this particular case, we'll install under Windows 10. So we'll go to the Python website, www.python.org. And when we get over there, this is what the website's going to look like. And so we can see that we've got kind of several different things we can look at. A little bit about Python downloads, which we're going to use, documentation, community of users that are out there, success stories, some news and those kinds of things. And in particular, kind of looking at scientific things. But if we go over to downloads, then we've got download for Windows. So we're doing Windows 10. And so if we click on that, we'll click save, and we'll wait for it to download from the website. So it shouldn't take very long to do that. And there she is. So now we can just run that. So open. And what do we want to do? Just to add things so that everything, all the paths are set, we can click add on Python 3.6 to the path where it's doing the searches. And now if we just click install, And of course, this video was made with TechSmith Camtasia, as you can see. And so during the install, so this is actual real time. Here's what we're doing while we're sitting here waiting for the little bars to go green. We've got Python 3.6. That's what we're setting up. Probably chose Windows because most people that are going to be watching this video series probably are going to be using it under Windows, and so this seemed like the most likely operating system to use. Chances are, if you're using this under Linux, then there's a pretty good chance you either have Python already installed, or if it's not, you know how to install it from the repositories, and so that's probably not something that I necessarily need to demonstrate. And so it looks like we are just about finished with the install process, so it's setting things up. Also under Mac, again, probably those kinds of things, you can look at the Apple Store, see what's in there, and install it from there. And so we're getting close. We're waiting. That little green bar is getting really close to being done. And voila! Setup was successful. Yay, that went pretty well. And so looks like now, for all intents and purposes, we have a working install of Python. All right, now let's take a look at what happens whenever we actually got for our install. And so if we come over here, we see this folder that says My Python. We open that up, and we see that there's already a script installed. And so if we kind of make that window a little bit bigger, we see that it is a Python file. It's actually the Hello World Python file. If we right-click on that, then we'll see that we have options to either open it or edit with idle. Now what we will be doing mostly is idle is our kind of integrated development environment. It's not much of one, but if we open it with idle, we see that we have something here. So this is what it says. It's printing Hello World, and that's kind of traditionally our first program that anyone writes in any particular language. If we had we clicked run on that, had we actually clicked on open, then Windows would have sent that file over to the Python interpreter and actually ran the program. Now if we look to see what programs actually got installed, pulling up the menu button, we see that we've got the idle Python interpreter up here. So that's our integrated development environment. So if we click on that, what's that going to bring up? Whoops, where'd it go? There. We brought up our integrated development environment. So I said there's not much of one. It doesn't have all of the bells and whistles that some of the other integrated development environments do, but at this point it's going to be pretty good for what we need to do. If we need to do a script, or we need to bring up a Python interpreter. So what it brought up when it loaded it was the Python interpreter, and so we can see the prompt that's there. If we open a new file, that's where we would write our scripts, and when we run our scripts, they'll show up here in the interpreter shell. So now kind of going back down, see what else that we have there. The Python documentation. So something that we will probably make pretty heavy use of if you've never programmed in Python before. Documentation to tell you what different functions are, how you use them, what the syntax is. That will be probably an invaluable thing. So probably between doing that and the going to the internet and trying to find examples of how to do those kinds of codes for what the syntax for a particular command might be. It's here, but if we want to see it in context somewhere else, it's also good to go look at it in the internet. We can see that all of the commands that we can issue are kind of listed right here. We've got what's kind of new in Python, the Python tutorial. So kind of that might be good for you to kind of skim through on your own, kind of see what's there as we're moving through the course, kind of this beginning section. So statements, loops, those kinds of things. See down through there. Pretty comprehensive stuff that we've got in there. And so if we, now let's see what else we've got. We've got the reference manual, the standard library. So kind of the standard library of functions that we are able to use right off the bat. So int, float, complex, we see those kind of coming up. We will make good use of those, and we'll see those in upcoming videos, kind of Python how-tos. A little bit of kind of more background tutorials, how you actually go about doing some things. And let's see what else we've got. Of course, frequently asked questions. So kind of general Python, frequently asked questions, programming, frequently asked questions, where are Python books, what is Python, what is the Python Foundation, programming, FAQs, those kinds of things, kind of general questions. So kind of good documentation that we've got, and so I encourage you to take advantage of that as it's listed there. Again, the internet is also a really good reference, and so with this I think we're ready to move on to actually start our Python programming.